Welcome to solverfy.
In this problem, we're going to compare three gases: hydrogen, helium, and CH4, which is methane. What we know about these is that all of them are in 5-liter containers. They all have the equivalent of 4 grams of gas in them. They are all at 273 degrees, 273 Kelvin. We say degrees for Celsius and Fahrenheit, but not for Kelvin. So the first thing we want to look at is the pressure. So let's look at the ideal gas law. PV equals nRT. So what we know is that temperature is constant and volume is constant. Now, the mass is constant, but let's not forget that mass is not this is not measuring mass. This is measuring the number of moles of a gas. So, given that far more molecules are needed of hydrogen to make a certain weight than they would be needed for helium, and CH4 would require only a few of the molecules, we know that H2 has the highest N. Helium just is in the middle, and then CH4 is at the bottom. So because of that, the H2 will have the highest pressure because these are directly proportional because they're on opposite sides of the equation. Helium will have the second highest, and methane will have the lowest. Next, this problem wants to ask about the average kinetic energy. So, average kinetic energy is an interesting thing with gases. So, it is calculated, I'm going to put this to mean average. It is calculated by 3/2 times the universal gas constant over Avogadro's number times the temperature. And this is true of all gases. So the only thing that really changes is the temperature. Since the temperature is constant for all of these are all equal. Oops. The next thing we want to know about is the diffusion rate. So, diffusion rate, the biggest thing that will influence this is going to be the particle size. H2, helium, and CH4 are all going to have different particle sizes, with H2 being the smallest, helium being in the middle, and CH4 being the biggest. So for diffusion rate, what matters is that with gases, smaller particles move faster. It makes sense. They have less mass, so they don't have as much holding them back. So a smaller gas will diffuse more. So in this case, diffusion, we've got highest for H2, helium's in the middle, and the lowest is going to be the methane. Next one this problem asks about is the total kinetic energy. Now, this should not be confused with the average that we talked about. In this case, we just want EK. And this formula is 1/2 mass times velocity or speed squared. So, mass, as I just discussed, increases. So theoretically, a bigger mass particle will have higher kinetic energy. But in this case, what is far more important is going to be the speed of these. Like I just said, smaller particles will move faster. And since this is squared, it's much more prominent. It's a much bigger factor when we're looking at things that while they differ in mass, they don't differ that much in comparison. So H2 will be the highest, and the helium will be in the middle, and the CH4 will be the lowest. Probably notice that there's often a pattern here. The next thing we're going to look at is the density. So, thing is, we actually know what the density is for all of these. Because earlier in the problem, we were told that these are 5 liters and that there's 4 grams. And density is simply the mass over the volume. So all of these have the exact same density because they all have the same mass, albeit with different amount of particles, and the same volume. So density is equal all across the board. Last one we want to look at is collision frequency. So there are equations to calculate this, but essentially the biggest thing is that higher speeds will cause more collisions. And the amount of space between particles also plays a role. But since these all have the same volume, essentially speed is what determines. And since smaller particles will move faster, they generally have higher velocities. We have hydrogen, then helium, and then methane. Hope this helped all of